32, and that power of 2 is 5. However, the second one, we have a base of e. And e, 2.718, blah, 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 blah. So having that number and trying to find an exponent that gives us 7 when it's already 2.718. So what would I do there? I can't really have just a nice number that works. So what can I do to solve that problem? Okay?
Change it to a logarithm.
Say it again?
Change it to a logarithm.
Yeah, we're going to change it to a logarithm. And in this case, Carrie, because it's e, we're changing it to the natural logarithm. Do you know how this gets switched to that form?
So the natural logarithm of 7 equals x.
Excellent. So we are going to be doing those conversions again. If I can't solve it the way it's written, our option is to change it then to its other form. So you can put this in your calculator. The natural logarithm of 7 will give us the exponent for e. And Dylan, that x value is?
How many decimals?
I'd say 2 or 3. 2.
1.946.
Okay, you give me 3. So, Dylan, in your calculator, if you do e to the 1.946, you should get approximately 7. Yeah. So, we probably couldn't come up with that number on our own.
Impossible.
Yeah. Without relying on our calculator. So, today, looking at those two conversions down below, remember that the log base A of x is equal to y, or a to the y is equal to x. And then the two properties underneath here, these are just properties of inverses. Don't get confused by them. But essentially, this is the first property of exponents that we've been using. If you have the log base A of a to the x, we know it just simplifies to that exponent. That's that third property that we were using to graph. It works the same way with logs and natural logs. So the natural log of e to the x is just equal to x. If I do its inverse and flip it around, and I have a to the exponent that's a log, because they're inverses, they cancel out. Just like if I have x squared and I take the square root, they cancel. So if I have an exponent to the log power, they cancel and they just leave me with x. And that's the property of inverses. Inverse operations cancel each other out. So I believe there are 5 questions underneath. One of those 5 is more interesting than all the other, and that would be letter D. Doesn't that one look interesting?
No.
The rest kind of just look boring. So it says solve the following for x. That look interesting to you?
Yeah.
Remember to check your answer into the original problem. What would we do to solve letter A? Colin?
You have natural log of 72 equals x.
Yeah, there's nothing else that we have to do to solve that. We just have to switch it into the other form. So the natural log of 72 is equal to x. And we'll keep 3 decimal places since Dylan gave us 3. It makes it a little more precise.
Thanks, Dylan. No problem.
4.271.
Yeah.
All right. So the second one, letter B, Brenton. What do you think you do there?
You gotta move the 5 to the other side.
Yeah. So just like when you're solving for x, you have to isolate that variable. Well, here we have to isolate the exponent. So e to the x equals 55. And then solving exactly like the other side, the natural log of 55 equals x. So Brenton, x is
4.007.
ooh, below 7. Letter C. What do we do with letter C? Lauren, what do you think for letter C?
Remove the 4.
And how would we remove the 4?
Divide it out.
Yeah, so divide by 4. Keep it exact. I know this ends up being an exact fraction, but if it wasn't, keep the fraction exact. Never round to a decimal until we get to the very end of the answer. So the less rounding, the more exact. So using the natural log, we're taking the natural log of 5/4. But Lauren, what's that going to be equal to? 2x. And then to get x by itself, I'm taking the natural log of 5/4 and dividing it by 2. Make sure you're using the whole answer of the natural log of 5/4 and cutting that whole answer in half or dividing it by 2. Do not round 3 different times in the problem. So round once, you round in your answer. Keep everything exact. So the natural log of 5/4 divided by 2, Lauren, is
0.112.
0.112. So again, natural log of 5/4 divided by 2, 0.112. No rounding until the end. We'll skip letter D. We'll do that last because it looks, again, more interesting than the others. Letter E says 2 to the x equals 10. Can we use natural log for this one? Regular log. Yeah, so this is the regular log. Remember, we can write this as an L that you guys showed me the other day. So the log of 2, my base is 2, 10, and then the equal sign, the exponent becomes what it's equal to. How do you put this in your calculator? Yeah, we talked about this. Use the math button. If you don't have that math button, you're doing the log of 10 divided by the log of 2. That's the change of base. The calculator has that formula it's embedded in it already. If you don't have a calculator that works nicely. Or you're going to math and it's letter A. So Josh, that number is?
3.322.
Any questions on those 4? Okay, so letter D says e to the 2x minus 3e to the x plus 2. What does it look similar to? Like concepts we've been working on this year. It looks very similar to a quadratic in that kind of form, that ax squared plus bx plus c. So Carrie, if you're a logical person, which I mean you dropped Mr. Kane's class, so you must be logical, right? Yeah. How do you think you'd solve a quadratic that's of exponents?
You could do AC grouping.
We could.
Could
Yeah.
do the quadratic formula.
Could use the quadratic formula.
The square is also an option.
Yeah, so we get 3 options. We can use AC grouping.
Can we do all of this?
You can do the quadratic formula. Completing the square would be a little tricky. A little tricky with the e's.
Do it.
But
We could do it anyway.
we could. I think factoring is probably the easiest way. And the least amount of work would probably be the factoring method. So if we factor, Carrie, 2 numbers that multiply to be 2, but combine to be -3.
-2, -1.
-2, -1. So usually, we have an x sitting there, but instead of having an x, we have an e. This e has a coefficient of 1, so this is the shortcut method of factoring. You're going to place an e to the x. And then the first factor Carrie said was a -2, not a -1. And then my second factor is e to the x, and then -1. If I multiply, what do you do with the exponents when you're multiplying? Add them. So x times x, or x plus x, makes 2x. So e to the x times e to the x. You add the exponents, and that's how you get that x, the 2x.
To the 2x power.
Say it again?
It just be e to the 2x power. Or it'd be 2e.
No,
E.
it's just e.
Yeah.
Yeah.
Just 1 times 1
Just
is
e.
1.
E to the x?
Yeah.
I don't know what you were asking.
You just 1 times 1 is 1. Yeah. Yeah, I'm good now.
Okay,
One
alright.
plus two is one.
So solving both of these, e to the x equals 2, e to the x equals 1. So now I'm going to have 2 answers because I have 2 quantities here. So the first one would be the natural log of 2, and the second one is the natural log of 1. Natural log of 1 is an identity, a property. What is the natural log of 1 always equal to? Zero. So that's that property. And then the natural log of 2, we got to plug in your calculator. 0.93?
No. 0.69.
3.
6.9.
Nice.
Questions? So when you see a problem that looks like a trinomial, you can factor it. You're factoring it with the e to the x, because when you're multiplying them, you're really adding the powers together. Questions? All right, so if you flip the page, we're going to change directions. So solve the following for x. Remember to check the original solution. When you start with a log or a natural log, what is the domain of a log or a natural log? So what can x be, or what can't x be, if you want to think of it like that? What types of numbers can't you have for x? You can't have 0. What other numbers can't you have for log or natural log functions?
Negative number.
Negative numbers. So the domain would be from 0 to infinity. You must check these x values back into the original. You don't have to do a whole check, but like a little mental check to see, does that solution hold true? Because if I get a negative answer, it might not work unless you have like a certain quantity in parentheses. A 0 doesn't work as well. So these you must check because the domain is 0 to infinity. The exponent problems, the domain of the exponent is negative infinity to positive infinity. So any x value is going to work as long as you algebraically solved it correctly. But with log functions, we have restrictions on x because it has to be a positive and cannot be 0. So the first two problems here, again, they look pretty straightforward. We know we have to probably isolate that natural log or the problem containing the x. So Gabby, what do you think you do for letter A?
Subtract the 5 on both sides.
So subtract the 5. And if we subtract the 5, we get negative 1. And then
Divide by 2.
divide by 2. So we have the natural log of x equals negative 1/2. Okay, it's okay that it's equal to a negative number because we didn't find x yet. So we have the natural log of x equals negative 1/2. How do you think you'd get x by itself, Josh?
You put e, and then you put it to the negative 1/2.
Right. So now we're switching it into exponential form, where when I had an exponent, we changed it to a log. If we have a log or a natural log, we're going to make it back into an exponent. So you kind of do the opposite. They're inverse functions. So depending which function you have, you do the opposite to solve. Josh, what is e to the negative 1/2?
X equals 0.607.
And that is positive. It is bigger than 0. And if I put it in here for x, it remains positive. So x equals 0.607. So again, it's all right that it's equal to a negative number because I didn't get x by itself yet. To get x by itself, we had to change it into the other form. So number 2, we have 2 natural log of 3x equals 4. So MH, what would you do to solve for letter B? Divide by 2. And then Emma, what would you do?
Make it eat,
Right. So if I wanted to get x by itself, I would divide by 3. Again, do not round. Use e squared, all of e squared, and divide that whole answer by 3. Round at the very end. So Emma, e squared divided by 3. Again, that's positive. It falls within my domain. If I plug it in here for x, it remains a positive value.
Yeah.
Brenton, question, stretching.
Stretch.
So the remaining 3 problems on here, there's 3, deal with equations containing multiple logs, I guess letter D doesn't, but the others have multiple logs or natural logs. And if I look at letter C, we have the natural log of x minus 2 plus the natural log of 2x minus 3 equals 2 times the natural log of x. So thinking about the properties that we were using this week, what do you think you would do to start trying to solve the equation? God bless you. Brenton.
Would you FOIL x minus 2 and 2x minus 3?
Why?
Because they be multiplied.
Yeah. So if we condense this together, multiplication is how I would kind of squish the two together to make it one natural log. So the natural log, and he said you would FOIL x minus 2, 2x minus 3. So addition, condensing it becomes multiplication. Brenton, what does that FOIL to be?
2x squared minus 7x plus 6.
And I'm putting parentheses around that because all of that is still attached to that single log, or natural log. On the other side, we have 2 natural log of x. Brenton, could you do with that 2 natural log of x? Yeah, make it an exponent. So the 2 becomes an exponent and makes it x squared. So looking at what we have, there is a property that matches the information we have. Anybody know where you go from here? It was the 4th property of the 4th. Garrett?
Is that 2x squared minus 7x plus 6 going to be equal to x squared?
Yeah. So if you have logs or natural logs that have the same base, so if the log has the same base, or if I have 2 natural logs, the property says that I can just take x, or whatever's after the first log, and set it equal to y. So essentially, because I have 2 logs here, the sides are equivalent because it's an equation, I can just solve that equation for the terms that are after the log. So I know that if I have an x squared, I have to get this equal to 0 to solve the equation. So taking the x squared to the other side. And Garrett, how would you solve x squared minus 7x plus 6?
You'd, what does that be? That'd be... I can't think of it.
What 2 numbers multiply to be 6, but add to be 7?
Oh, negative 6, negative 1.
There you go. Negative 6, negative 1. So x minus 6, x minus 1. So we have 2 answers of a positive 6 and a positive 1. Now, yes, both of those answers are positive. But if you go back to the original problem, if you plug a 1 in for x, that 1 is getting subtracted by 2. And whatever's after the natural log in parentheses must remain positive. If you plug 1 minus 2 in, you get a negative 1. So even though it appears that it should work because it's a positive number, you have to go back to the original problem and see what is with that natural log, or is there anything connected with x. This does not work because it becomes then a negative 1. If I use the 6, making sure to check that, 6 minus 2 is 4, so that's good with the first one. The second one, 2 times 6 is 12. 12 minus 3 is 9. And over here, it works because it would just be a 6. So when you look at your answers, don't just say, oh, they're both positive, so they have to work. It doesn't work back into the original problem. Questions? So it must work into the original problem. So I'd like you to try letter D. Log base 4 of x minus 9 equals 3. Log base 4, x minus 9 equals 3. So think, what do you have to do to solve?
Excuse me. Yeah.
Josh, why is it so easy?
Because you just put it in the thing.
Yeah, exponential form. So make a big E.
Yeah, that's a.
And what does it become then, Josh?
4 to the third equals x minus 9.
And 4 cubed is
64.
64.
I don't know why.
Sorry. And when you add 9,
Yep.
you good?
X equals 73.
X is,
I was doing it as,
Yep.
as 0.
that's all right.
Okay, I got it.
So if I plug a 73 in, 73 minus 9 is 64, and it still remains positive by plugging it in for this x. I have x right up there.
Yep.
I don't want All right, the last one on here.
Yes, sir.
What would you do if it says minus, Dylan? Or Josh?
Oh, you got it.
Divide. So we're taking 3x minus 2 divided by x minus 3.
That's good.
Remember, you only have one log. That log is outside. It's not part of the fraction. It's separate. And then on the other side, it's equal to 1. Dylan, what's the base that there isn't one written?
10.
10. I think my mind was thinking that I needed to have a base there. So Dylan, how would you write this then?
10 to the first equals 3x minus 2 over x minus 3.
Nice. So once you do everything you can as it's in log form, you've condensed it. The option is then to change it to an exponent. So now we have 10 to the first is equal to 3x minus 2 divided by x minus 3. How do you solve this problem? Colin?
Multiply both sides by x minus.
Yeah, whatever's in the denominator, we need to get out of the denominator. So in order to get rid of it, I need to multiply by it on both sides. So we have x minus 3 that we're multiplying with 10, which gives us 10x minus 30. And then on the other side, that x minus 3 is gone because we multiplied it. And we have 3x minus 2. So Colin, if we get the x's on one side, numbers on the other, what do we end up with?
Or you get 7x plus 28, or equals 28,
Equals 28.
and then x equals
So check that 4 back into the original problem.
Oh, yeah, it's good.
Plug it in, 4 minus 3 is good. 2 times 4 is 12, minus 2 is 10.
Oh, yeah, that's good.
Give that a little circle. Questions?
Oh yeah, it was good.
Good.
So your homework is solving equations. That's all equations.
Let's go.
Half of them are exponential form, either with a base numerical value or the e. The other half then would be the log or the natural log form. I'm going to give you back those tests that you took on Monday, those chapter 2 tests, so that you can look at them